Welcome to today's session. Let us discuss about the jet transform. And we all know about the DTFT of an sequence, discrete time Fourier transform, and we apply this DTFT for the sequences x of n. And you all know about the Dirichlet conditions. So for getting the DTFT of a sequence x of n, that is x of e power j omega, the Dirichlet conditions have to be satisfied, and in that, for this should be absolutely summable. The sequence x of n should be absolutely summable. That is, the summation x of n mod minus infinity infinity should be less than infinity. Okay, so if this was satisfied, this condition is satisfied, then DTFT exists for such sequence x of n. Okay, and there may be some sequences where this doesn't satisfy, this condition doesn't satisfy. So some sequences doesn't satisfy the above condition. Okay, that is doesn't satisfy above condition, that is summation x of n okay, that is not less than infinity, or simply it will be infinity. Okay, n equal to minus infinity infinity. And for this condition, I mean, if the x of n is not absolutely summable, then DTFT doesn't exist. So what we should do? So if the DTFT doesn't exist, is it not possible to find out the frequency content of the information? Okay, so let us once see the DTFT of the sequence, that is the DTFT of x of n. Okay, that is x of e power j omega summation x of n e power minus j omega n equal to minus infinity to infinity. Okay, so for the sequences that are not absolutely summable, the DTFT doesn't exist. So what should we do? So let us consider that I want to multiply the x of n with some r power minus n, some sequence. Okay, I'm going to multiply the sequence x of n with r power minus n, some convergence factor. Okay, I want to make the sequence absolutely summable, so I'm going to multiply your x of n with r power minus n. Then what happens? This is x of n into r e power j omega power minus n. Okay, so this is nothing but x of n that is summation x of n z power minus n. So z equal to r into e power j omega, where n equal to minus infinity to infinity. So this is x of z. So x of z is summation x of n z power minus n. So this is nothing but DTFT of x of n into r power minus n. So we are going to choose a proper r value to make the sequence x of n to converge or absolutely summable. Then you can find out the DTFT of such sequence. So this leads to the Z-transform. Okay, so x of z is summation n equal to minus infinity to infinity x of n z power minus n. Okay, and where z equal to r into e power j omega. Okay, and this one is a complex variable. Okay, where z is a complex variable, you all know about it. Okay. So let us solve some sequences Z-transform, that is the basic one. Consider x of n equal to a power n u of n. Okay, provided that a is in between 0 and 1. So x of z is, so here I am considering the limits as n equal to 0 to infinity. Why? Because it's a u of n that is existing from 0 to infinity. Okay, n equal to 0 to infinity x of n z power minus n equal to 0 to infinity. What's x of n? A power n z power minus n, a into z power minus 1 over n. So n equal to 0 to infinity. So you know that about this, an infinite geometric progression series. So for such cases you can get the answer as a by 1 minus r. So where r is the common ratio and a is the first term of that above summation, and this one is the common ratio. So you will get the 1 by 1 minus by 1 minus a z inverse, that is z by z minus a. So while defining x of z, you have to give for what values of z this x of z is valid. Okay, so the summation, the above summation, you have seen the summation that x of z, which is summation a z inverse over n equal to 0 to infinity. Okay, so to get a proper value or else a finite value for the x of z, this common ratio should be less than 1. Okay, for getting finite value or valid one value, common ratio should be less than 1, then only the summation will converge. The sum will converge. So that is a z inverse mod should be less than 1. So this gives to mod z greater than a. So we will get x of z a finite value when z is greater than a only. So we will plot this in the z plane, that is the ROC is, this is the circle of radius a. Okay, so you know that z equal to r e power j omega. R is the radius of circle and where omega is the angle. Okay, where omega is the angle. So the ROC is z greater than a. So in this z plane, for all the values z greater than this, for all those values z greater than a, the x of z exists. Okay, for the values of a less than, for the values of a z less than a, the x of z doesn't exist. Okay, so x of z is finite, or x of z exists, simply can say x of z exists for z greater than a, that is region of convergence. That is the region of convergence for what values of z. Okay, the x of z will converge. So this is called the region of convergence, or ROC. So the ROC is z greater than a. Okay, so let us see another example, and you observe this one is an causal signal. Okay, a right side infinite sequence. Okay, so you note the point that x of n is right sided sequence. Okay, for the right sided sequence, the ROC is outside the circle. Okay, outside the circle of a particular radius a. Okay, so let us see another one, that is the sequence considered is x of n is minus a power n u of minus n minus 1. This one is an left sided sequence. Okay, a left sided infinite sequence, and again the provided condition is a between 0 and 1. Sorry. Okay, so for this sequence, let us find out x of z. So x of z is again the summation minus summation, okay, a power n, okay, and this is u of minus n minus 1. So this is existing from n equal to minus infinity to minus 1. Okay, u of minus n minus 1, okay, exists from minus infinity to minus 1. Okay, and we have a minus negative values, so minus is taken care. So x of n is defined like this, and z power minus n. Okay, so let me convert this entire sequence in the range of 0 to infinity. So I will add 1 and I will subtract 1. So n equal to minus infinity to minus 1 a z. So a power minus 1 z power n. So minus 1. So this entire term I will write it as 1 minus summation n equal to 0 to minus infinity. Okay, right. Okay, did I make any mistake here? Sorry, this one is the positive. Okay, so this is, let me rewrite this one, a into z power minus 1 whole power n. Okay, so I will write this one as the summation n equal to 0 to minus 1, and this one is included into this expression. So n equal to 0 to minus infinity, so a z inverse n. Okay, now I will change the limit values. Okay, so n is from 0 to minus infinity. I will convert it to the positive n value. So 1 minus summation n equal to 0 to infinity. So I am changing here the n values. Okay, and a z inverse power minus n. Okay, and I am rewriting this as n equal to 0 to infinity a inverse z power n. Okay, so now let us find this sum. So this is x of z. So one is a finite value. So now for what values of z this sum will converge. Okay, for what values of z this sum will converge, and let us find what is the sum. This is obviously is an infinite series. So 1 minus a by 1 minus r. Again the first term is 0 by 1. The first term is 1 by 1 minus a inverse z. Okay, so 1 minus 1 by 1 minus z by a. So what you will get here, again let's expand this entire expression, x of z equal to, okay, 1 minus a by a minus z. This will be a minus z minus a by a minus z. So we will get again z by z minus a, z by z minus a. So observe here x of z is z by z minus a. So for what values of z this is the sum will converge? Let us see, a inverse z, okay, be less than 1. Okay, z by a less than 1. So z value less than a. Okay, mod z value less than a. So the ROC is, I mean the region of convergence is mod z less than a. So what's the sequence here? The sequence is x of n equal to minus a power n u of minus n minus 1. Okay, the x of z is z by z minus a, and mod for values of mod z less than a. So the ROC is, if you plot this thing in the z plane of radius a, the z value less than a. So inside the circle of radius a. Okay, inside the circle of radius a. So for these values of z inside the circle of radius a, the x of z exists. Okay, beyond the values of a, beyond the values of a, and for such values of z, x of z doesn't exist. So you find the difference between the previous question and this one. So let us observe things. X of n, the previous one is a power n u of n. The x of z is z by z minus a. But this ROC is z greater than a, and this is the right sided sequence. So for the right sided sequence, the ROC will be outside the circle of a particular a value, and for this left sided sequence, the ROC will be inside the circle. Okay, let me plot for this one also. So all the values outside the circle in this z plane, the ROC will be like this, and for this left side sequence, the ROC will be inside the circle. Okay, left sided sequence, left sided inside the circle, and right sided outside the circle, the ROC. Okay, so by understanding these two basic problems, you can solve the Z transform of any question. Okay, let us consider another one where we take the two-sided sequence. Okay, x of n equal to b mod n. Okay, and the b value should be a positive, and let us define for what values of b the signal, I mean the Z transform will exist. Okay, so consider b value is greater than 0. Okay, we are considering b value greater than 0. So for the b value greater than 0, okay, but it should be less than 1, then you can get the sequence like this. So b between 0 and 1, you get the sequence as like this. Okay, the summation, I mean this will be absolutely summable for such b values less than 1 and greater than 0, and for the b greater than 1, if you observe, the values will gradually increase as you move away from the origin, I mean 0, the values will increase. This is not summable. Okay, so there will not be any common ROC for the b greater than 1. Okay, there will not be. This one is the right sided sequence, the combination of right and left side sequence. So for such sequence b greater than 1, there will be no common ROC. So when there is no common ROC, there is no x of z. X of z doesn't have a finite value. Okay, so let us consider for this one only. So b in the range of 0 to 1. So the x of z will be, I will give the expression as 1 by 1 minus b z inverse. Okay, and 1 by 1 minus b z inverse, sorry, b whole z inverse, bz whole inverse. So the ROC will be mod z the B and 1 by B. Okay, if you plot the ROC of this one, it will be a circular strip. It will be a circular strip like this. Okay, and this will be B and this value will be 1 by B, and the ROC is inside these two circular rings, and this is the common ROC. Okay, let us see how you will get. So for the right sided sequence, the ROC will be outside the circle. Outside the circle, the ROC is for this right sided sequence. And for the left sided sequence, the ROC will be inside this circle. Okay, if you overlap these two these two ROCs of this left side and the right side sequence, you will get the common ROC just like this. Right? Okay. So let us solve another one. What's the Z-transform of del n? Delta Fn. So x of z is, you know about the summation n equal to 0 to, or else minus infinity to infinity, del n z power minus n, and you know that del n exists only at n equal to 0. Okay, so n equal to 0, you will get value as 1, and this is for all values of z, that is ROC is entire z plane. ROC is entire z plane. Okay, so no exclusions. For the delta, it covers each and every frequency component. So what about del n minus 1? Okay, Z-transform of delta of n minus 1. So x of z summation delta n minus 1 z power minus n equal to minus infinity infinity, and you know that exists at n equal to 1, so z power minus 1. So this is 1 by z. So for getting a valid x of z, z should not be 0. Okay, so for valid x of z or finite value, or for valid x of z, z should not be equal to 0. That is, the ROC is entire z plane except z equal to 0. Okay, so plot that ROC z plane except this value, except this, the ROC is entire z plane. It covers each and every frequency component. This is like the Fourier transform del t. So the Fourier transform of del t is also 1. Okay, delta t is also 1. It covers each and every frequency component for all values of omega. It covers all frequency components delta t. Okay, same you can take that del n plus 1. Okay, for the delta n plus 1 Z transform of del n plus 1. So x of z summation delta n plus 1 z power minus n minus from in the ring minus infinity infinity. So this del n plus 1 exists at n equal to minus 1. So you'll get z. So x of z is not defined at z equal to infinity. Okay, z is at z equal to infinity, the x of z is not defined. So ROC is entire z plane except z equal to infinity. So you observe here a finite duration sequence. Okay, for the finite duration causal sequence, you will get the ROC except z equal to 0. So like let us take a sequence that is x of n, the like 1 2 minus 1 3 minus 4. Okay, so for this one, if you find out, if you represent this x of n in terms of impulse, that is x of n equal to 1 into del of 0 plus 2 into del of n minus 1 minus 1 into del of n minus 2 plus 3 into del of n minus 3 minus 4 into del of n minus 4, like this you can represent. So to take the x of z, so del of 0, okay, transform is like this, not del 0, this is del n. Okay, del n Fourier transform is 1 plus 2, del n minus Fourier transform is 2 into z power minus 1 minus n minus 2 Fourier transform z power minus 2 plus 3 into z power minus 3 minus 4 into z power minus 4. So this is 1 plus 2 by z minus 1 by z square plus 3 by z cube minus 4 by z power 4, this one. So the ROC is except z equal to 0, except z equal to 0, it covers entire z plane, except z equal to 0. The same for the right sided sequence, or for the left side, this one is a right sided sequence. Okay, the right sided sequence like this: 1 2 minus 1 3 minus 4. This is a sequence 0 1 2 3 4 x of n. This is the right sided sequence, right sided a finite duration sequence, a finite duration causal sequence. So for such signals except z equal to 0, okay, it covers entire z plane. Okay, so similarly for the left sided sequence, okay, for the left sided sequence, by x of n equal to 2 1 2 1. Okay, the left sided sequence defined like this. One, two, 1, and 2 at n equal to 0, 1, 2, 3. So you can write this x of n as 2 into del of n plus 3 plus 1 into del of n plus 2 plus 2 into del of n plus 1 plus 1 into del of n. So the x of z is 2 into z power 3 plus z power 2, 2 into z plus 1. So the ROC is entire z plane except z equal to infinity. So at z equal to infinity, the x of z is not defined. Okay, so these are the basic points for the Z transform, right? So we will discuss, or we will practice some more problems in the next sessions. Thank you.